triangles, we've already been working with right triangles, and we found that if we just use SOHCAHTOA, and we know at least one of the angles and one of the side lengths, then we could figure out another side length. But there's a special relationship when you have these types of triangles. So we'll start with the 45, 45, 90, because that's a little easier to work with. So when we have a 45, 45, 90 special right triangle, there's special relationships between the side lengths. So 45, 45, 90, try to draw this where the two legs are the same length. It's a right triangle, and that means that the angle measurements are 45 degrees and 45 degrees and 90 degrees. There's a special relationship between the side lengths when you have that. Do you know what kind of triangle this is called? As well as a right triangle, it is also called isosceles. Yeah, when two sides are congruent. So therefore, we get to label, here's part of the relationship. Those two legs are the same. It's totally symmetric. It's isosceles. And what I'm going to prove to you in a second is that the hypotenuse would then be the leg length times the square root of 2. Like that, x root 2. So that is the formula. I'll box that. You want to memorize that because you don't want to have to derive it every time. But I'm going to derive it once really quickly. So it's very simple where it comes from. It's Pythagorean Theorem, which we should review anyway. Leg squared plus leg squared equals hypotenuse squared. So watch this. We already know those are both x. So you go like this. X squared plus x squared equals hypotenuse squared. I'll call it h squared. Everyone agree that's true? If these two legs are the same, a squared plus b squared equals c squared, right? And now I'm going to solve for h, and you'll see when I'm done with solving for h, I get x root 2. So what do you get when you add those? 2x squared, exactly. We combine like terms, we get 2x squared equals h squared. And now what do I do to solve for h? To undo square, I square root. We don't need to worry about the negative version because a side length isn't negative. So you get the square root of 2x squared. And we're almost there. So a proof something like this would be a good extra credit question. This is, do you see how that's x root 2 right here? X squared, square root is just x, right? Here, I'll show you. It's root 2. We can break it apart like that, right? Any radical, two things under it that are multiplied, we could break it apart. And the square root of x squared is x, so it's x root 2. Okay? So since you don't want to have to do that every time, you memorize x root 2. Okay, so let's practice some examples. Now some people said earlier, oh, the reason we want to do this is because it makes it easier. Well, sometimes. And I'll start with the ones that make it easier. So let's say, so the goal here is to find whatever missing side lengths are given. So let's draw a triangle in the same orientation as the notes. Let's say this is unknown, that's A, that's 6, and that's B. We can put our letters anywhere we want. So I want to find A and B. And I know it's a 45, 45, 90 because they said that that's 45 degrees. So what are A and B? Okay, well, we compare it to the formula. You know that A is 6 because it's the same as the other leg, and the formula tells us that. And what's B? 6, 6, and 6 root 2. That is all you do. There's no work to show. You don't have to use SOHCAHTOA. And the answers are better than using SOHCAHTOA. You could have used SOHCAHTOA. I want to make that clear. You could have. But you would have gotten some ugly decimal for 6 root 2, and we have to have exact values. As when we get to the unit circle, you'll see everything around it is in exact values, which are more precise than a rounded decimal. And that is why we do the special right triangle, to get exact answers. Okay. So let's try another one where it's really fast and easy. We like it when it works out this way. So let's say we were given, let's draw it like this. Let's say that's our right angle. It looks like a Dorito or something. I don't know. So let's say this is A, B, this is 45 degrees here, and we're given this is 11 root 2. So what are A and B? Compare, right? Match it up. So what are A and B? So what is it? 11 and 11, right? So in those examples, it makes our lives easy. There's no work to show. But now, of course, I got to throw something else in there. So let's say it looks like this, which is more typical because you have to show some more math. 3 root 2, and this is A, and this is B. And this, of course, these are all 45, 45, 90s. Let's see here. What are we going to do there? Well, what's the easier side to do? A or B? B. Yeah, because it's the same. The legs are the same. What is B? 3 root 2. Okay, that was easy. Same. Now, the hypotenuse is, look at the formula. It's the leg length times the square root of 2. Right? So you gotta plug that in here. So it's gonna be, so A is gonna be 3 root 2 times the square root of 2. Okay, so now we got to simplify that. So that's 3 times root 4, which is 3 times 2, or 6. They do get harder, but so you have to be careful which side you're given. You have to use the formula. So questions on that one? All right, let's do the 30, 60, 90. So the formula for 30, 60, 90, which is derived on a different video, but I won't here, is you could easily look it up. It'd be a great extra credit question. 30, 60, 90 looks like this. Here's the formula. So I like to draw it like so that it's kind of tall. It's like standing up, because that means this will be the bigger angle, 60 degrees, and this will be the smaller angle. To me that's standing up. The triangle's standing up taller. So the bigger angle is here, the smaller is there. And now try to memorize this now, otherwise you can derive it. The relationship is this. The hypotenuse, the longest side, is twice the shorter leg. So how do I write that with symbols? 2x and exactly. So that part's easy, right? Now this, you could use Pythagorean Theorem. Leg squared plus leg squared equals hypotenuse squared, and you could derive it, but you will get, this is x root 3. Okay, so that's your formula for the 30, 60, 90. You should either memorize it or be able to derive it. So let's look at some examples here. So we'll do one easy and one hard on this. So let's say first you have to make sure the orientation is the right way. So let's put it the same orientation, and you'll know because I'll say that 60 degrees. And let's say these are the unknown sides, and this is 10. This is the easiest kind of example, because what do you know about A and B? A is 5, half of the hypotenuse, and B is 5 root 3. Done. So sometimes we love when it's, that quick and easy. So now let's do one harder one. Yes. Are there any, so if I match this up, so 2x and x, so this is half of that, and then whatever leg length you get here, you just multiply it by the square root of 3, so 10, 5, 5 root 3. And then let's try one more that would be the most difficult kind. I'm going to put it in the same orientation, standing up. That's supposed to be the same as last time. But let's say I say this side is 5, then these are unknown, A, B. So this will be the last one. Okay. So what you do is you take the given side, you match it up with the formula, and solve for x. So see how 5 is equal to x root 3? You just literally write that. 5 is equal to x root 3, or we could say x root 3 is equal to 5. And once we solve for x, we'll know what the other sides are. And that's it. So how do we solve for x? You divide by the square root of 3, right? If you want to get rid of it, you have to divide by it. Right now it's x times the square root of 3. So the only way to get rid of it is divide by it. 5 over the square root of 3. Now here's something I haven't emphasized much, but I need to now, is we don't want radicals in the denominator. Otherwise your unit circle isn't going to make sense. So what can I multiply the square root of 3 by so that I don't have to have it, yeah, the same thing. Just multiply by the same thing. And that will get rid of it because this is the square root of 9, right, on the bottom? Right? And what's the square root of 9? 3. And on the top? Well, on the top, now we have the radical on the top, but that's okay. So it's 5 root 3 over 3. You're going to see stuff like this in the unit circle. Yes, it looks harder, maybe, but it's more precise. So now we know that A is what? Yeah, that is A. Yeah, that is A. So A is 5 root 3 over 3. And B, the hypotenuse, is? How do you do twice that? How do you times it by 2? Do you times the top and bottom by 2, or just the top? Just the top, right? It's like multiplying by 2 over 1. So what do you get? 10 root 3 over 3. And if it's simplified, I would simplify, but see how it doesn't simplify, right? You can't divide the 3 into the root 3 because one's in the house and one's not.